first feature I want to show you is dependency visualization via exploration view or cycle view. In that case, I can just right click on anything here in my navigation view, show an exploration view, and in this case I only want to see the incoming dependencies for the module dependency management. Create me this graph here, so you can see those arcs are dependencies. They're going counterclockwise, so the arcs are going counterclockwise like this, means on the left side they go top down. So we have quite a bunch of modules using dependency management. If I drill down here, I can already see a cycle between those top level packages, which is kind of a problem, and if I drill down further I can see even more cycles down here. Cycles can also be visualized over the cycle view. In this case we go to the cycle groups window, look at all the cycle groups found by Sonargraph, and in this case I'm going to look for Java file cycles, also known as component cycles. And look at that, we have another big cycle here in this dependency management module comprising 69 Java files, and I can visualize that like this here. So now you see a lot of different colors, which is kind of bad news because the colors basically come from the parent packages. So everybody who is in the same package has the same color, and we see that this cycle does not only comprise classes from one package, but actually classes from many different packages. The second feature I wanted to show you are our 3D tree maps, also known as software city view. So what you see here is basically an interesting visualization of a software system. Each of those little buildings is a Java file in this example. The footprint of the building is proportional to the size of the files and lines of code, and for height and color you can pick arbitrary metrics. In this example we used code churn of the last 90 days as our color metric and the average complexity as the height of the buildings. And what we would be looking for here would be red skyscrapers. Those would be Java files that are complex and change frequently, so they're very good candidates for refactorings. In this example we don't have any red skyscraper, but you can see how useful such a visualization could be to find interesting spots in your software. The third and last feature I wanted to show you today is our architecture DSL, which allows you to define architectural models using a domain-specific language that we created for that particular purpose. You could think of that language as UML component diagrams in text form. So let's create a new architecture definition here. We call it command controller because we want to ensure that our command and controller layers are behaving as designed. And I pre-created that so that you don't have to watch me typing here. It's a very simple little architecture here. So we define basically two artifacts, which are boxes in architecture diagrams. The one box contains everything from our command layer, the other box contains everything from our controller layer. And the rule is that command can talk to controller, but not the other way around. Now what happens if I activate that rule here? I have to add it to the architecture check. We can see that we have obviously some architectural problems here, which are displayed down here. We actually found two violations, and I can directly jump to the source code and find the first violation. You can see that I cheated a little bit here, so I just inserted this here so that we would find an architecture violation, but you could see how quickly you can detect rule violations by defining your own architectural models.